Hey everybody, I'm going to be working through, by popular request, one of the problems from the assignment. I think my class called it 00C. It was the lines and parabolas one. Let me open it up just so you know which one we're talking about here, in case you're trying to decide if this is something you want. So basically, this is the assignment. Basically, a couple students requested that I make video for this just to kind of talk through it, which is a great idea. Like, this is challenging. This is the first assignment I wrote for Accelerated, so basically, like, I was trying to gauge levels a little bit. But after talking to at least one of the students, we agreed that we thought question 3 was probably the best one to do. So I'm going to do A through, I think it was H. A through H on problem number 3 from this assignment as video solutions, and then I'll post that video for you. I apologize in advance just because I'm sort of tired at this point and getting close to sort of the sleepy by time, but I wanted to make sure to do this now because I'm not sure if I'm going to get to the rest of the weekend because I've got a couple other things going on and I've got a calc test to write. So without further ado, this is question number 3 from the lines and parabolas assignment. So we're going to kick things off with part A. The question stem is written on the screen in the upper right hand corner, probably right above me where I'm at, and it says the graph of P of x below consists of 2 parabolas and a line segment. So first of all, this entire thing is what we're calling P of x. And by the way, there's a little flaw in the picture. There should be arrows right there. So let me just add them so we got it. So P of x consists of 2 parabolas. So that would be a parabola right here. I'm just going to write parab. And then also a parab on the far right side. And then it also features a line segment in the middle. So of course we can see that. So there are 3 separate graphs in here. And the reason I'm bringing that up first is if you're struggling with this, a good way to start is just to think about what is it that you're going to need to find. And you're going to need to find the equation of the first parabola, the second parabola, and the line. So basically all of that is asked in this question. But just FYI, that's a good way to kind of start and go, okay, here's the lay of the land. As it says, use the graph to answer the questions. So first question on here is not even related to using the equations themselves. It's just purely analysis, meaning can't install updates. Too bad. The first question on here is actually nothing to do with like finding the equations of the parabolas or the lines. It's focused completely on just pure analysis, like looking at the visual of the graph and determining what intervals we are strictly decreasing. So basically strictly decreasing, if you recall, is when we're running from a max to a min, or a high point downward. Like there's a couple different things. You all kind of know the trend there. So basically we're looking for the sections where that happens. And I see 2 sections right off the bat. I see a section right here, and I see a section right here. The good news for us, those points are all labeled for us. And in order to express the intervals on which P is strictly decreasing, we need just the x coordinates of those. So we're going to say x is an element of, we're going to go -2 to 1, and then union to connect these two together, saying it's either the first one or the second one. And then we are also going to have 8, 9. So again, nothing that isn't straight out of Math 2 there. You're just looking at the picture and looking for the parts where you're going from max to min or high point to low point. And there are those 2. So use the x coordinates as well. Part B is where we start getting into sort of the, as I say, the lininess and the parabolist. We're getting into the linearity and the quadratic elements of this problem. So it says, first, find the equation of each parabola included in the graph of P of x. And so what I'm going to do is I'm going to color them here. I'm going to call this first one the pink parabola. You can tell it's the pink parabola because I just wrote it in pink. And then the other one we're going to call the green parabola. So we're going to do the one on the left first, and then we'll do the one on the right. And I will say this is going to take a little bit of work. Might have to do a little bit just to make sure we figure out what the value of A is for each of these, but I'll show you what I mean. So as we dig in here, before we do anything else, as a reminder, the equation of a parabola in vertex form is given by A times the quantity x minus h squared plus k, where your vertex is going to be the point given by h comma k. So given that, and given that we have the vertex of the pink equation, the pink parabola, and we have the vertex of the green parabola, we can start out and write almost the entire equations for these 2 parabolas right off the bat. We just need to interpret these x and y coordinates as h and k in our vertex form equation. So for the pink parabola, we're going to have y equals a. We don't know a yet. That's what we're going to have to find. That's kind of the crux of the problem. X minus a -2. So that's x minus -2. I'm just writing it as x plus 2 squared, and then plus 4. Again, the 2 came from the negative 2 that was there as the opposite sign, and the plus 4 came from the y-coordinate. It was the same sign. Likewise, on the second parabola, we have y equals a times. Our x-coordinate is 9, so x minus 9 squared. And then our y-coordinate was 1, so plus 1. And again, those points, 9, that was a terrible arrow. You can tell it's a Friday and I'm exhausted. So our x-coordinate, or h, was 9, and our y-coordinate, or k value, was 1. So there it is. Those are our two equations. Now you'll notice, though, and hopefully you're already objecting, that there is something missing here. We are missing the value of a, the leading coefficient. So we don't know what it is. It could be 1 each time. That's always a possibility, but it might not be. So we need to figure out and solve for a. And I will say this is a challenging thing. This is definitely something challenging. We did it really briefly in my class at the end of the notes. It's probably not the thing that stuck with you, but I'll show you how this process works. What we're going to do, and I'm going to use a different color for this, the same color twice so that way you can see that it's the same process. What we are going to do is we're going to take a second point on the parabola, like for instance 0, 0, and we're going to plug it into our vertex form equation. So specifically, we're going to plug in 0 for y and 0 for x. Now, as a heads up, if you wanted to, you could also have plugged in 1 comma negative 5, because that's also on the parabola, but I'm choosing 0, 0 just because oftentimes 0 is really easy to work with, just one of those things that helps. So when I make that move, what does my equation become? I'll use pink now. Our equation becomes 0 equals a times 0 plus 2 squared plus 4. I'm going to simplify this down. That's going to be 0 equals a times 4 plus 4. So in other words, 0 equals 4a plus 4. I can subtract 4 from both sides. I'm going to try to show every step here and be careful, but at some point I may sort of realize time's crunching on me, and I'll shorten up a little bit. And then finally we'll divide by 4. So after all of that work, we get that a is equal to negative 1. And that's a lot of work to get there, but we needed that. It wasn't going to be the equation of the parabola without it. So finally we can take that a value and plug it in right there yonder. So that's going to be y equals negative 1, or just negative, both are acceptable, times the quantity x plus 2 squared plus 4. Oops. Come on. And by the way, if I'm going through this and you're like, it's going too slow, of course you can skip to the next chapter. That doesn't bother me in any way. You can also speed up the video. Basically, that's why I talk so methodically, because YouTube allows you to speed up the video. That's why I like hosting on YouTube. So it's definitely not for the lucrative cash I get, because I don't have 1,000 subscribers yet. Just lots and lots of watch hours and videos. Okay, so what's next? We're going to do the exact same thing on the green parabola. In this case, the only point we have to choose from is 8, 3. So, sorry, I'll use red. The only point we have to choose from is 8, 3. So basically, we're going to plug in 8 and 3 for x and y, respectively. So 8 is x, so we're going to put 8 in right there. And y was 3, so we're going to put 3 in right there. When we do, we get a new equation that only has a as a variable. That's a times 8 minus 9 squared plus 1. So cleaning things up a little bit, this is 3 equals a times, this is negative 1 squared, which is just 1, plus 1. That means this is 3 equaling a plus 1, and I'm hoping you're okay. I'm going to slide through the step. You could subtract 1 from both sides. You're going to get a equals 2. So our leading coefficient in this case is 2, positive 2. And we're going to have y equals 2 times x minus 9 squared plus 1. And there is the equation of the second parabola on this graph. And now as a heads up, we've answered question B, and it seems like, gosh, it's taken forever to answer question B. But keep in mind, we use these equations over and over again in this problem, because we're going to keep referring back to the parabolas that are in this graph. So we're going to go back and find x-intercepts. We're going to go back and find where certain y values occur. We're going to go back and we're going to try to find things intersections. Basically, this is a good investment in the rest of the problem, like I imagine the next part will be as well. So just keep in mind, a little bit of extra time at the beginning, carefully finding these equations will pay off as we go forward. So moving on to letter C, number C, we'll see. So question C asks us to find the slope of p of x at x equals 7, and what is the equation of the line segment defining p of x for 1 to 8. So let's just say this is maybe not perfect, but that looks like about where x equals 7 is going to be. And we're curious what the slope is first at x equals 7. Now you might be thinking to yourself, well shoot, we don't know what the y-coordinate is. How could we calculate the slope? But keep in mind that x equals 7 corresponds to a point on this very line. Basically, it's just a point on that line, which means the slope is the same at every single point along that segment. So in other words, if we want to find the slope at that point, we can just calculate it like normal. We'll do the y2 minus y1, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then we'll plug in those coordinates. I'm going to choose to let this be y sub 2 and x sub 2, and I'll let this one then be x sub 1 and y sub 1. So plugging in, we've got 3 minus a negative 5 over 8 minus 1. So notice I'm being very careful with the ordering here. I've got negative 5 and 1, or excuse me, negative 5 and, did I do that right? Yeah, negative 5 and 1. There we go. God, Jesus, I'm tired. Negative 5 and 1, and then on the other one, we have 3 and 8. So those are the corresponding points, y coordinate, x coordinate. Good stuff. So from here, we've got the slope if we simplify this. In fact, we can see it's going to end up being 8 over 7. Cool. There's our slope for the line. And then from there, if we want to write the equation of the line, we can do that with point-slope form really easily. We just select one of the 2 points over here, either this one or this one, and we write the equation from it. So if you'll recall point-slope form, so PS form is y minus y1 equals the slope times x minus x1. That actually comes directly out of this equation, by the way. You can look at that and play with it a little bit more. We talked about it briefly in class. So in here, I want to plug in everything. So I'm going to choose a point. I'm just going to choose, I think this one looks cooler. So we're going to have y minus 3 equals our slope 8/7 times x minus 8. And this is the equation. They wanted the equation, we have it. The only thing I'm going to say, though, is I want to take this just one step further, and I want to actually rewrite it in mx plus b form. I want to write it in slope-intercept form, just because I think it's going to be easier to solve with it in slope-intercept form. So bear with me for a second. I know that I can finally cheat on this stuff and copy and paste a little bit. Basically, what I'm going to do, and I'm going to use this color to do it, I'm going to first distribute the 8/7. So I'm going to get y minus 3 equals 8/7 x minus 64 over 7. And if you're less comfortable with fractions, you might read that as 8 over 1, so you can just multiply across. Likewise, I need to add 3 to both sides. That'll get me y by its lonesome. And we'll still have 8/7 times x. But over here, we're adding 3 to 64 over 7. Let's get a common denominator by multiplying up and down by 7. And that's going to give us minus 64 over 7 plus 21 over 7. And with that given in place, we can now simplify this a little bit. This is going to be y equals 8 over 7x, and then that's going to be, I believe, minus 43 over 7. Let me do a quick check here just to make sure. That's going to be 64 minus 21 is 43. Yep, and we were negative. So there is the equation of our line. We've got it in point-slope form, and we've also got it in slope-intercept form. And again, big investment. Took us 4 minutes, but we have a big investment now in being able to do stuff with that line. Question D. So with this information, question D asks us to find all the intervals where p of x is positive. And I will say, I think part of what makes this question in particular, this is one of those whoo boy, really, really difficult questions because there's a hidden piece of information, actually 2 pieces of information that are hidden here that you have to find first. I think that's honestly part of what makes this tough. You know, I'm going to use orange. Those hidden pieces of information are these 2 x-intercepts. Actually, let me use a different color for the second one. So the reason we need those 2 x-intercepts is that we're trying to find where p of x is positive. We don't need to know what they are to identify where that happens. P of x is positive right here, and p of x is positive right here. We're just looking for positive too, by the way. Just where is the graph's y-coordinate positive, or where is the graph above the x-axis? So we have 2 sections to go with. Good news for us, we have that this section in the beginning ends at x equals 0. That's helpful. We know 0 is going to be one of the endpoints of our interval. The problem is we don't know the other x-intercept here, nor do we know the x-intercept right there on the line. So to do that, we're going to actually have to solve for those 2 pieces. And that's the hidden piece that you have to do in order to get somewhere that sometimes can just look like utter gibberish if you're not careful. You're just looking at it going, where did they get that from? So, and I was just checking on my solutions to see if I added anything. I said you need zeros to determine this. So basically that's what we're going to do. We're going to find the zeros on the first parabola, and we're going to find the zeros on the line. So first of all, let's go back and grab those equations. So recall we did some work here. So the parabola on the left was given by this, negative x plus 2 squared, all plus 4. So I'm going to bring that back around. And then likewise, we just played with the equation of the line. We got that puppy right over here. I mean, those intercept and slopes are a little bit rough because the puppy, get it. But basically, there we are. Those are our two equations. So from the one on the left over here, we are going to get this x-intercept. So let's do it. How do we qualify an x-intercept? An x-intercept is a point of the form number, comma 0. In other words, we want y to equal 0. So let's set y equal to 0. We'll have 0 equals negative quantity x plus 2 squared plus 4. I'm going to move the plus stuff squared over to the other side. This may be non-traditional. Some of you might not like this, but I think it's going to do the trick. I just wanted to get rid of the negative sign as fast as possible. So there's our stuff. We want to solve for x plus 2, so I'm going to square root both sides. Square roots get rid of squareds. They're inverse operations, using that new word. We're going to get x plus 2 on the left. On the right, we have the square root of 4, which is 2, but because we took the square root, plus or minus are there, we could have either possibility. And then finally, we can subtract 2 from both sides. Apologies. Minus 2 from both sides. We get x equal to negative 2 plus or minus 2. In other words, x could be negative 2 minus 2, or x could be negative 2 plus 2. That is, x is negative 4, or x is 0. So interestingly enough, we already know x equals 0. Like there is x equals 0, so we're covered there. This one you're good. This part that we found, though, means that this x-intercept is at negative 4. So we found our first x-intercept, and we can write out at least half of our positive intervals. But you know what, let's just get the other one out of the way too. What the heck, we're here. So over here, once again, we're talking about an x-intercept. That's where y is equal to 0. So let's set y equal to 0. We get 8/7 x minus 43 over 7. At this point, I would probably personally multiply the whole equation by 7, but I'll play along for the moment. I'm going to add 43 over 7 to the other side. This is one of those places where I'm not going to show every step in perfect gory detail. I'm sorry. From here, I'm going to multiply both sides by the reciprocal of 8/7 so that we can make a 1 there. So 8/7 times 7/8. The 8th will divide out. The 7th will divide. The 7s will divide out. We'll be left with on the other side. Oh, some more 7s divided out. We're going to be left with 43 over 8 equals 8x. Nope, the 8s divided out, didn't they? Jeez. Hey, we're done. Look at that. We're left with 43 over 8, which is somewhere in the range of 5 point something. That looks pretty reasonable to me. 43 over 8, comma 0. So now, after all of that work, remember we were trying to find these intervals where p of x is positive. Now we can label them because we know where they cross the x-axis. X is going to be an element of negative 4 to 0. And then union the other section, which looks like 43 over 8, comma infinity. So again, I don't think the analysis part, weirdly enough, is actually the bit that's going to be difficult. I would say that what makes this tough is simply the fact that you have to know to find the x-intercepts for both the parabola and the line, which definitely something trippy, not something that's going to automatically like pop into your brain. Poof. But there's how we do it. So we found those things using those equations we'd located earlier. Question E. I think question E is sort of a time suck problem. What I mean is that each one of these things requires a little bit of work, and that can be a challenge, like depending on how much information you've got from your graph. So first of all, what is it asking? It's asking us to compute 3 function values. And for the sake of coloration, I'm going to go ahead and label them in different colors here on the left side. We're supposed to find P of 9. We're supposed to find P of 3. And we are supposed to find P of 10. So basically 3 function values to find. Now, in your mind, you might go, well, okay, we've got all those equations. And in fact, it might be valuable to even bring those in right now just so we've got them handy. Can just take the whole thing? Yes. Yes, yes, yes. Yes, there we go. Okay. So what I'm trying to do is I just want to bring these equations in so we've got them handy, just because we're going to be using them throughout the rest of this problem set. So basically, I just want them around. How can I get you? No, okay, that's not it. I don't want them alone. I just want them here. Okay, so there are the first two, and then let's go get the original one, the original green one. There it is. Oops. Cool. So there is the green portion. Oh, I put the Parabolas equation in the wrong spot. There we go. Got it. Okay. So there are 3 equations for the 3 parts. The reason I wanted to start there is that in order to calculate something like p of -9 or p of 3 or p of 0, we have to know which part of the graph we're on at that point. So for instance, when it says p of -9, we need to figure out which of these pieces has -9 on it. But we can see that. On the parabola on the left, we start at 0, then we go to -2. -9 is going to be somewhere over here. So I don't think it's going to be quite there if it's drawn to scale, but it's going to be somewhere on the left. So we're going to be plugging -9 into y equals negative quantity x plus 2 squared plus 4. So let's do that. Negative quantity, -9 plus 2 squared plus 4. And then let's simplify it. We're just finding a function value. That'll be negative times -7 squared plus 4. That's going to be equal to -49 plus 4. And that's going to be equal to -45. So good stuff. We got our first one. Second one, p of 3. The next question is, well, where the heck is x equals 3? Well, we're going from x equals 1 to x equals 8 here, so 3 is somewhere in the middle. So to find 3's value, we're going to be plugging into... This is confusing color-wise. Sorry, I apologize. I shouldn't have done green. Let's go with navy blue. There it is. So navy blue. So back to the point. X equals 3 is somewhere in the middle, so we're going to be using the linear equation to calculate out that y value. So if we plug in 3 to that equation, we'll have 8/7 times 3 minus 43 over 7. Simplifying a little bit, I'm seeing 24 over 7 minus 43 over 7. And again, I'm not going to go into the gory arithmetic here. It's not that bad. It's just it's annoying. We're going to get -19 over 7, or a shade under 3. Finally, we're going to look at p of 10, and you can probably predict where 10 is going to fall just based on the fact that we're kind of following this pattern. So 10 is going to be over here somewhere. That's going to be plugging into the positive parabola with a equal 2. So let's do it. Again, let's not beat around the bush. 10 minus 9 squared plus 1. Looking at our ingredients here, we're going to have 2 times 1 squared plus 1. That's 2 plus 1 is 3. So the y-coordinate at x equals 10 is 3. So cool stuff. We've got what we needed, and we were again using those equations that we invested some time in earlier in the problem set. Question, I was going to say 4, but it's the letter F. Those are different things. Find all intervals in which p of x is both negative and strictly increasing. Now, when you read this question, you may recognize it. Something very similar, what we would probably call a cloned question, meaning it's exactly the same, just asked with different numbers or a different graph. This was on our quiz 001A or quiz week 1, however, I don't remember what we named it. So, in other words, we're looking for a section of the graph where 2 separate properties hold. We want the graph to be negative. We want the graph to be strictly increasing, so getting bigger. Now, to help us a little bit here, I want to go through and label those x-intercepts that we don't have on here just to make sure that we've got that down for the rest of our work. So based on what we did, we found that this x-intercept was -4, so I'm going to give it a nice robust dot. We already had the one in the middle, which was 0, 0. That was given to us, super generous. And then the last one was 43 over 8. So let's go ahead and plot that down. Just so we got it, that's 43 over 8. So the reason I want that is I want to make sure we know where all the important pieces are on this graph, so that way we can just do the analysis. So let's see. We want where the graph is negative. That's going to be a section that's down here. Our candidates are those 3. So basically one of those 3, maybe 2 of those 3, or 3 of those 3 will be what we're looking for. So the negative part, we got 3 candidates. Actually, let's leave those circled for a second. 3 candidates right there, 3 candidates. The next thing we want to hit is where the graph is strictly increasing. So out of these 3 different candidates, which one is moving in the upward direction? For which one do you start low and end high? And the answer would be, you definitely do right here, and you definitely do right there. And given that, we have 2 separate intervals where this graph, p of x, is negative and increasing, strictly increasing. Those will be the values of x between negative infinity and negative 4. I would totally understand, by the way, if you put negative infinity to, what was it? Oh, man, I had something I thought was very profound to say. It is gone. It's gone. I'm sorry. So we're going to put from negative infinity to negative 4, and then on the second section, we're going to run from 1 to 43 over 8. So once again, having your answers or your equations and your work carefully done and readable and legible for you to go back and look at from before is a huge lift for you as you're digging into this stuff, for sure. Next we got G. I think this is the second to last problem we're going to look at. Is that true? Yep, second to last problem we're going to look at. Next we want the left and right end behaviors. So first it's just worth reminding you what that looks like. The left end behavior, which is a description of what the graph is doing as you move all the way to the left or all the way to the right, basically as you go towards x equals infinity or negative infinity. Basically on the left, we're going to say, as x approaches something, I'll just leave it blank, how about that? As x approaches something, f of x, or in our case, p of x, because that's our function name, p of x approaches something else. Actually, I'll leave them there. So that is the left version. The right version is going to look eerily similar. And for this, I'm going to take advantage of the fact that the setup is exactly the same. So there we are. Okay, now, the question is, what are the left and right end behaviors? So easy way to tell. Go all the way to the far left end of your stuff. For me, it's pointing right. I'm hoping for you it's pointing left. We'll find out. So we're going to go all the way to the left and go, which direction is this pointing? Is this going up? Is this pointing down? Or is it just going sideways forever, as though it's going to stay stable the entire time? In this case, we are going downward, which means we are approaching negative infinity. In addition, since we were moving to the left, as x approaches from this side, as we approach this thing, we are approaching negative infinity as well. So basically, in both cases, we are approaching negative infinity. And that's what we'd say. As x approaches negative infinity, p of x approaches negative infinity also. Thanks for playing, friends. On the flip side, if we go to the other side, we want the right end behavior, and we can see that happening right here, is going up. So p of x is definitely going to be approaching infinity or positive infinity, for what that's worth. X, though, is going to be moving to the right side. And on the right side, we would say that's where we're moving towards this idea of positive infinity. So we'll write that as x approaches infinity or positive infinity, p of x approaches infinity or positive infinity. And that is end behavior. Like, let me quickly fast over here, see if that's what I did. Oh yeah, I don't think I wrote it. I guess I wrote it correctly. It was just I didn't see what I boxed. So there we go. There is question G, just straight up end behavior. And then finally, we are going to do the last question that I had required in my class. Again, if you did more work, that's totally fine. That's actually great. I think those last questions are really good challenges to kind of help you see if you've really got everything down. And don't mind me for bringing these equations back that clearly there's no reason to do that for now. So what does H ask? H asks for us to find all values of x for which p of x equals 1. So let me give you a visual of what that looks like. So p of x equals 1 is the same thing as saying where y equals 1. So the idea is, if this is y equals 1, you could draw a line straight through. I know it's not to scale. Give me a second. I'll come back and fix it. You could draw a line through all of those pieces, straighten the puppy out. Oh, jeez. Come on. Did it really just leave that entire thing? Can you believe that? Did you see that? Did you see that thing? There we go. Okay, so there it is. There's our spot. It's crossing at y equals 1. What we want are all the x values where there is an intersection point, meaning where the graph of y equals 1 or p of x equals 1 crosses the graph of p of x. And the cool thing is, I see that multiple times. I see one such intersection here, and I see a second intersection here, both on that parabola on the left side. Likewise, I see, let me get a color here. I see an intersection here on the line. So we'll get to that. And then finally, like looking at it, you're like, oh man, there still might be one more. And in fact, there actually should be. I just did a really cruddy job of trying to make it make contact with the graph. Because the y-coordinate there is +1. So there is one extra point where it intersects, and that is the vertex of the far right parabola. So we have 4 separate, what's the word I'm looking for? We have 4 separate x-intercepts that we're supposed to look for, and we need to find each one. And all 3 equations are going to be used in this case. So let's see where this is going to go. So we'll start with the red ones. So right here, we want to find those 2 x-intercepts. Or excuse me, those 2 places where y equals 1. So what we're going to do is we're going to take that equation, which we found earlier. Again, we invested real time into this. And we are going to set this equal to 1, because we're trying to find what x value gives us y equals 1. So when I do that, I get a bunch of different work to do. Your approach might be slightly different. I'm going to subtract 1 from both sides and add the squared thing to both sides. That's just kind of a personal choice. If you feel differently, so be it. I'm comfortable with my choice. So moving that over, we're going to get 3 on the left. On the right, notice all these things zeroing out. That zeroes out. That zeroes out. We literally get 3 equals x plus 2 squared. And then once again, we can solve some stuff by square rooting. We're going to get plus or minus root 3 equals x plus 2. And then I can subtract 2, and I'll get x equals -2 minus root 3 and -2 plus root 3. 2 separate possibilities. And oh wait, that's a good thing. There are 2 separate places where this graph crosses y equals 1. So that's actually exactly what we needed. We have found our first 2 x values, the 2 that correspond to that parabola on the left. So 2 down, 2 to go. The next one we're going to hit is the line. So we know the line is given by 8/7 x minus 43 over 7. We want to find when that line attains a y value of 1. So okay, we solved this equation. How about we do this? I'm going to multiply everything on both sides by 7. I said I would do that again. That was just my plan. So I'm going to distribute 7 in. I'm going to get 8x minus 43. And on the right side, we're going to get 7. From there, I'm going to add 43 to both sides to try to get the x alone. How can I get you alone? How can I get you? Is that an 80s song, I think? I don't know. I am beyond the saturation point of exhaustion, but I can feel the ending here. So we're going to get x equals 50 over 8, or if you're a simplify kind of person, that's going to be 25 over 4, also known as 6 point, is it 5? No, 6 1/4. Yeah, it's going to be 6 1/4. So 6.25. Any of those possibilities is great. So there's our blue one. So good stuff. Now, we said there were 4. We can see a green circle on the page, or a gray circle for those among us who are color challenged. Having said that, though, there's no actual solving here. We can see there's just one intersection point, and we also know what that intersection point is. So you're welcome for me giving you one clean one. Based on that, the last point is going to be when x equals 9. And again, that one is just from the graph. We can see it has a y-coordinate of 1, so therefore it is a value, and in fact is the 4th value. We have done our job and gotten our 4 intersection points, basically. And do they match what I got over here? Let's see. Yup. Looks like we got it. So from here, there were more questions. It extended out beyond that, but I decided not to ask those just because I felt like they became increasingly challenging or just increasingly time-consuming. And I'm glad that I did, because that means I don't have to do them right now, because I am exhausted. My eyes feel so tired, but I got it done. So having said that, as I always say, thank you for watching. More than that, though, thank you to the 2 students that specifically asked for this video. I'm sorry it won't go up right away. It takes a little bit to render the video at home. If anyone wants to buy me a brand new video editing computer, I could probably make use of that. But I'm just kidding. I'm okay. I'm good. But hopefully these solutions are good for you as well. So without further ado, thanks for watching. Thanks for asking. And have a great weekend and night and life and month and even a year. 'Cause I'll be there for you. I need to sleep.